Welcome to the PhotoModeler Single Photo Road Skid tutorial. This tutorial demonstrates a technique often used in accident reconstruction work. We describe the measurement and mapping of some skid marks given only a single photograph taken by an unknown camera. Control points are needed to complete this project. Control points are known 3D XYZ coordinates of points that appear in the unknown photograph. The control point information may be obtained through a survey of the scene as it exists today. This survey can be done with PhotoModeler or with survey instruments like a total station. For this type of project, one typically has 5 or more control points with a good spread over the photograph. We start a new points-based project, navigate to the directory where the photo is stored, and import the photo of the scene. In this tutorial, we have a digital image, but you may have a physical photographic print. When you scan this photographic print, make sure the print is carefully set up on the scanner to be square, not canted or rotated, and that the crop rectangle is the same size as the print. Do not cut off any part of the photograph and do not add any white border to the scanned image. Since we do not know anything about the camera that took this photo, we select Unknown Camera. To rebuild the camera information, something needs to be known about the scene. In this case, we have some surveyed 3D points, so we select the parameters to be solved by control points or imports. PhotoModeler's inverse camera function has the ability to solve for 3 different camera parameters on the unknown camera: focal length, principal point, and format size. By default, only focal length solve is turned on. The Camera Setup Wizard computes a reasonable format size given the image size and the assumption of square pixels. For this reason, format size usually does not need to be solved for. In most cameras and with a well-scanned photograph, the principal point, where the optical axis of the lens hits the image plane, will be close to the center of the image, which is where the Camera Wizard places it. Focal length of the camera is something we rarely know in this type of project, so it is best to solve for it alone first. If you have a very good set of control points, more than 10 of them with a good spread over the photograph, and you suspect the photograph may be off-center due to prior reproduction problems, then you can try solving for principal point after the whole project is done to see if it improves results. You can add format size also if you have even more control points and you suspect non-square scanning pixels. These settings are adjusted in the Photo Properties dialog. We click Next. The initial project setup is now complete, and we are ready to begin working with the single photograph. We open the Project Cameras dialog and can see the default parameter guesses that have been assigned by the wizard. Open the Photo Properties dialog by right-clicking on the image thumbnail. You can see the camera's focal length will be solved for during processing. We will begin by marking control points on the image. Control points are known 3D XYZ coordinates that appear as distinct marks in the unknown photo. Control points are generated by a survey of the scene. This survey could come from any source, like a total station or a separate PhotoModeler project performed using photographs from a known calibrated camera. We open up the Imports viewer to bring our control data into the project. Data can be imported into PhotoModeler as a DXF, OBJ, or 3DS file, manually entered using the Modify Import tool, or as a text file. The format of this text file is described in the PhotoModeler Help file. We click Add Imported Object and choose survey.txt, which is a text file we created using a text editor like Notepad, based on data obtained from a survey. The units for this file are in feet. We change the units to feet. It is a control type import, meaning the survey data will define the coordinate system used by PhotoModeler and can be used to calculate the inverse camera parameters. Points are fixed. Click OK. The file has been imported. Holding the mouse over the type column will give you details about the imported object. In this case, it is 15 points. We can see a 3D version of the imported data in the window here, or we can select the list view to see a spreadsheet layout of the data from the control file. We mark the control points by switching to Mark Control Points mode and selecting the point from the list, then moving the mouse over to the photo and marking the control point accurately where it should appear on the unknown photo by clicking the left mouse button. Double-click to open the photograph. Select a point from the list and move over the photo. You want to mark points that are easy to see in the image, are non-linear, and that have a good spread across the photo. We mark the top of the fire hydrant here. We use Alt-Zoom to mark as accurately as possible. The marker on the road there. Because automatic processing is on, once we mark the 5th point, the project automatically processed. You can see the photo is now oriented, and if we go back to the Project Cameras dialog, you can see the camera's focal length has been adjusted. Note that the solved focal length is proportional to the camera's format size values, which were fixed by the camera setup wizard. If the initial format size values had been different, the solved focal length would have been different also. One needs to be aware that the solved focal length is not an absolute value and does not necessarily reflect the actual focal length of the camera that took the photo. The solved focal length is equal to the focused focal length of the lens only if the format size entered in PhotoModeler matches the true physical format size of the camera. Regardless, the results produced for measurements will be accurate. If we open the 3D viewer and turn camera stations on, we can see the camera's position has been solved. We'll add some additional control points to strengthen our solution. As we mark the additional points on our survey, each new mark refines a solution, improving and strengthening our project. We switch to line mode and add some lines between our earlier marked control points. This will help with visualization. Now when we open up the 3D view, the lines and 3D marks are visible. It is a good idea to review the residuals of the project. The largest one is always displayed on the status bar here, but you can use a point table to get an idea of how large all of them are. You should examine the points that have high residuals, then recheck the control points to make sure they have been marked accurately. We'll save the project as adjusted.pmr. We now add a surface to define the plane of the road. We select the Surface Path tool. While in Path mode, we select the object to define the plane of the road. We want to define them in a clockwise direction so the surface faces the camera. You can see the surface of the road here. We also define one for the opposite side of the road. If we had selected the objects in a counterclockwise direction, the surface would be facing upside down. We can use the Flip Surface command to correct the surface that was last drawn, or the selected surface if you want to select a specific one. The most important information in this project is contained in the skid marks. If we had multiple photos of the scene, we could add detail by marking and referencing points as demonstrated in other tutorials. Since we only have one image, we will use PhotoModeler's Surface Draw tool to trace the shape of the skid mark. Surface drawing allows us to draw on or trace detailed features on surfaces using only one photo. Surface drawing requires no referencing, so it is very useful for adding detail to single photo projects, but can be used in multiple photo projects also. To do surface drawing, PhotoModeler requires a 3D surface that projects on a photo with a solved camera. That is, you must have solved the project successfully to generate a solved camera station. If we turn on 3D surfaces, we can see the projected surface in the photograph here. The skid mark is not completely covered by surfaces. We don't have enough points on the road to connect more surfaces. However, Surface Draw allows us to continue modeling the skid outside the surface, as long as we start marking them within that defined surface. We call this Extended Surface Draw. There are a few skid marks that need to be marked. We zoom in using the scroll wheel and begin marking the one on the left. We are now outside the surface area, but it's still using that plane for the surface draw calculation. Come back up the other side. And mark up this side here back near the start and connect to the point at the start of the skid. Right-click and select End Draw. Turn off 3D surfaces so we can see our photo more easily. Over in 3D, we can see the true representation of the skid from our surface draw markings. If we turn off surfaces, we can just see the skid marking. In Select mode, we can go back and fine-tune any of our surface draw points if we are not happy with their initial placement. We traced both sides of the left skid mark using the Surface Points Line Mode tool. In some cases, it will be the best tool to use. In other cases, you may want to use the Surface Points Curve mode. We will use this tool for the right skid. The Surface Draw Line tool draws line segments between each surface point you place. The Surface Draw Curve tool interpolates a curve through each point as it's placed. Click and end Curve Draw. With the 3D viewer open, we look at the skid marks from a top-down view as if we were directly above the road. We can see the true shape of the skid mark shown by our surface draw markings. We save the project as marked.pmr. We can get some measurements directly from PhotoModeler by opening the Measure pane. Our scale and rotation is defined by the control points we've imported and marked. You can measure in the 3D viewer or the photo. Here we will measure in the photo. Choose one endpoint from the skid, hold down Shift and select the other end. Here it tells us that the distance between the two skid points is 44.98 feet. Note that this is a straight line distance between the 2 points chosen, and not the distance along the curved path. You can measure straight line distances between other pairs of points if you wish. Or Shift-select a combination of line segments to get their accumulated distance to measure just a segment of the skid. On the right skid, selecting the Surface Draw curve will give you the total distance of the curved skid mark. From a single photo from an unknown source, we have been able to determine the length of this skid mark. We can continue performing measurements of the skid marks, or we can export the data to a CAD program for further work or diagramming. We can also create an orthographic view of the image. What this means is PhotoModeler is able to take image data, remove all perspective, and remap the image so that it appears as if the view of the image was from the top. This allows the true shape of the skid marks to be presented in photographic form. Orthophotos extract information from the part of the photograph that is covered by surfaces. We must make sure that the full skid mark is covered by surfaces. We can expand the surfaces using Surface Draw. We start by clicking inside a regular surface, then outline the rest of the road. This region should be included in the orthophoto. We can now switch to Path Surface mode and create a surface using our newly drawn surface points. If we look at this in 3D, you can see our skid is now covered with surfaces. There's a small gap in the surface which we can fix by extending our Surface Draw. The plane is now covered by surfaces. To create our orthophoto, we select File, Exports, Export Orthophoto. The Photo Export dialog appears. There are a number of settings you can adjust to control the orthophoto. These settings are described in the help file. In this case, we will leave the defaults. You can click the Update Preview button to generate a low-resolution version of the orthophoto. The skid marks are at the top here. If we wanted to view the skids at the bottom, we could select Rotate 180 degrees and re-update our preview. Now, these are our skid marks down at the bottom here. Here is the image size of the output orthophoto. You could increase the size depending on the resolution of your input images and the amount of perspective. Click Export. Choose to save this file as ortho.jpg. Orthophoto is completed, and we get the success message. Click OK and close the orthophoto dialog. The orthophoto can then be opened in any imaging program such as Photoshop. Here we take a look at our exported orthophoto in a separate imaging program. With perspective removed, we can see the true shape of the skid mark. We'll save this project as done.pmr. This concludes the tutorial on single photo road skid projects. We have demonstrated how to use inverse camera, surfaces, surface draw, the measure pane, and orthophoto export to analyze the road scene from a single unknown photograph.